right, y'all. So let's go ahead and deep dive right into this. So what I've got set up here is a little simulation of what you would find inside the wall of your house. I've got some lights here. I've got some receptacles there. And I also have white right here. I'm using a switch only because I don't have a panel on me. But every single time I say I'm turning off the breaker, okay, which would be like saying I'm going to my panel and I do that, right? I'm just turning the circuit breaker off. What I'm doing is I'm actually turning off a switch, which is interrupting the circuit, but it's all still the same, okay, in principle. Just understand what I mean when I'm doing that, okay? And what I'm going to do is I'm going to show you utilizing different tools that you may or may not have or are going to get, and hopefully you will do and keep inside your toolbox. They're very inexpensive. You can get them on Amazon, you can get them at Lowe's, you can get them at Home Depot, so on and so forth. Ace Hardware even has a lot of these things. But I'm going to teach you guys a new ditty. So you guys remember when you're in boot camp, they had things like eyeballs and you would say snap, right? Like it's that something to learn and how to perform that function. I'm going to put another one in your toolbox and we're going to call this one live, dead, live, okay? So that's going to be the process we're going to use every single time to ensure that everything is de-energized. So let's go into our first one. This is a very typical thing you see in a lot of homes. It's a stud finder, okay? You buy these because you're trying to find that wood that, or known as a stud inside the wall, because there's drywall there. You can't see where the stud's at. You need to be able to anchor in the stud because you're hanging a TV, because you're hanging a shelf, or hanging a really heavy picture or something like that. So what this equipment does is it will illuminate to let you know once you're over the stud. You can mark it on the drywall, and now you know you're going to find where that stud's at. Well, what a lot of these other models have is something right here. It says AC for alternating current with a lightning bolt and has an LED. And what that does is it will illuminate and let you know whenever you are over an electrical item that's located inside the wall that you can't see as such. So what I'm going to do is I'm going to push that down. All my lights came on, the green light's on, so I know that my meter is working correctly. And then I'm just going to pass it along the wall. And now you can see that that red light illuminated, letting me know that there is electrical wire that's behind the wall, and I need to be cautious. So let's use this first to figure out that process. The first one being live, okay? I know my equipment's working properly because I got a green LED right there. I go across, and then there, okay, now it's detecting that. So I know that I'm hitting a live circuit. Now what I'm gonna do is I'm gonna shut my circuit breaker off. Now to ensure that I properly de-energized it, I'm gonna turn this back on. Now I have nothing, okay? Now I'm not gonna turn this off. I'm gonna come down here to something that I know is not turned off. Gotta make sure it's not turned off while I'm still holding the button. Okay, and I'm going to test it with something that I know is on as of right here. I know this is on, it just went off, so now I know that this meter is properly working. Okay, so what I'm going to do is I'm going to do a live, dead, live. Okay, or I'm sorry, live, dead, live. Okay, so let's go through that again. I know it's working. Live, okay, live, dead, live. Okay, now why did I do it that way? Because I need to make sure that this is working properly, okay? That's the only purpose whatsoever. Some people would be like, oh, well, it's a little excessive. Obviously, it's not, you know, the equipment's gonna work or whatever. No, I've actually seen very expensive digital voltage meters, which I'll show you here in a little bit, that a lot of electricians, a lot of people use in electrical work, where the internal fuse is actually blown, and so they just walk up to it to turn the circuit off. They walk up and they just plug the fluke or the meter in, and it goes, hey, look, it's zeros. That means there's nothing there, and they end up getting shocked, right? So live, dead, live is to stop that from happening. Again, so let's do it with a different piece of equipment. Let's go with this bad boy right here. Okay, this is a voltage sensor. And it just detects that magnetic field around it. So I'm gonna go ahead and it's got this, for mine, it's got this thing that says NCV. We're gonna hit that. It's gonna light up to let me know that it's working. Another way you can test these, and I do recommend it, make sure your equipment is working properly, is on a voltage sensor, you can actually rub it against your shirt and it will beep, and it's because it's reading the static electricity that's coming off of your shirt as you want it. That's an easy, super easy field method that you can use to make sure this is working properly. Now let's go back into what we were doing before. So I still have my circuit breaker in the off position, and I'm going to want to test live, because I know this is live. Say this is my kitchen and this is my bedroom, and I'm working in the bedroom. So the first thing I'm gonna do is I'm gonna come over and, okay, that's a live circuit. Now I'm gonna come over to this one. Nothing, right? Now I'm gonna come back over to my live circuit. Okay, see, live, dead, live. I just made sure that it was exactly off. Next one I'm gonna do is, you guys remember this one from the GFCI video? I like this one because it's stupid easy. It is so easy to quickly identify, and a lot of times when you're doing repair, you don't want to do this all throughout your entire weekend. You've got work on Monday, I get that. So try to get the job done as quickly as possible and as safely as possible. So what I'm gonna do, I'm gonna go back to my kitchen, and it's simple. The lights are on, okay? That's live. Now I'm gonna come over to my dead. Yep, lights are definitely off. I'm gonna go back to my kitchen. Yep, it's definitely live. Again, I've tested to make sure this is properly reading, so I know 100% this is exactly off, okay? Last one I'm gonna show you guys. It's gonna be this, your digital voltage meter. Now they're gonna look different. They can come in different sizes, shapes, colors, it doesn't matter. Voltage meter is a voltage meter. Just wanna make sure that if you look on every single meter, it'll give you a code right there, or a category code, and it'll tell you the max amount of voltage that you can put onto that meter. Please do that before you start poking and prodding things around. Some can be 300 volts, they can be 600 volts, it can be 1,000 volts that they can take. Just make sure you understand that you have up to 240 volts inside your house. So this one can take up to 300. This is perfectly safe. I bought this at Harbor Freight for, I believe, it was like $9, I think. Stop shaking. But you can go as high as, I have a $450 Fluke that I use for certain applications. You don't need a $450 piece of equipment. This little thing right here, this stupid little cheap one here, is just enough to work just as good, because it has two different leads. It has a red and has a black. Now you don't have to worry about them so much, okay? That's not really what matters. What you want to know is what setting to properly put it on in order to use it. Now, there's two different settings here, if I can get it to focus. There's like a line with dashes, and then there's like that squiggly line. We want the squiggly line, and we want, you see where it ends with V? That's for voltage. We want to check voltage. Don't do A, okay, it's amperage. That's not what we want to check. We want to check for voltage, okay? And you can see right now, it says 0. This is where it's gotten electricians in trouble in the past, because they see that, they see that and they say, okay, well, obviously it's dead, so I'm good. No, it's because your meter's not working properly. So again, live, dead, live. I'm gonna take the meter, my two leads, I'm gonna place one on one side, I'm gonna place one on the other, and now it's telling me there's 122 volts that's in that circuit. Now I'm gonna come over to the one that I'm gonna be working on. I'm gonna do the same thing. And now it's telling me I've got 0, okay? That's fine. Now we tested the dead, let's go back to the live. And look at that, I have 122 volts. So I know my meter is properly working, and I know that 100% I've turned this off. Now I'm gonna talk about a few caveats on these. So let's go back to the first one that I talked about, which is gonna be your stud finder. You need to understand that your stud finder is not always gonna be perfect and how it's gonna work, because it can only detect the electrical when it's in proximity to it. Okay, this is a proximity sensor. If I turn it on, okay, so now it's on right now, I've got the green LED, and I place it on this, it's telling me I'm on a stud, but the AC did not light up. Matter of fact, if I come over here, nothing, okay? The reason for that is because the wires are too far away for this sensor to pick it up. It's more used to finding wires that are close to inside the interior of the wall, okay? So if that's the case, I'm gonna have to take this plate off carefully, because knowing that it could possibly be live circuits. I'm going to have to take this faceplate off, which is just 2 screws right there, and then I'm going to have to get this really close to the screws in order to detect that there's any type of voltage there. This one is obvious when it comes to restrictions, because obviously I need to be able to plug this thing in. There's no plugs here. Now there is a kit that exists out there for some of you guys that are electricians. I know you can do the kit. Most homeowners are not going to buy that kit, okay, because it's actually really expensive, and they're only probably going to use it maybe once every 1 to 2 years maybe. So we're going to count this one out, okay. Again, this one, the voltage sensor, can also still be used, but this still uses a proximity sensor, which is very similar to the one is over here. So again, I got to take the faceplate off in order to make sure that there's no electricity within those wires, okay? Because as you can see, I'll even try, test it and show it to you, to prove it. Nothing, okay? Now, going back to the meter. Same thing with the meter. The meter's test leads, these little metal pieces right here, they got to make contact with that metal in order to know, right? That's why I had to shove it into the receptacles in order to know that there is no voltage on this thing. So again, with a light switch, I get it. You're like, hey, I'm turning it on and it's not lighting up. Yeah, I get that. That doesn't mean that this is a good bulb, okay? If the bulb just blown out the 3rd or 4th time that you turn this on, okay, there's still going to be live wires in there. So there's a different way you can do it. You can either come in here into your light switch, say you're working on your light switch, take this faceplate off and check the wires there, or you could actually take the light bulb out and test the contacts that are inside this light bulb socket. So what do I mean by taking the faceplate off? It means exactly that. So what I'm going to do is I'm going to take the faceplate off. All right, so now we got that out of our way. All right, so right now I've got everything exposed. Now I'll show you the difference. Remember, it didn't detect very much. And again, I'll go ahead and do a little quick test. It's definitely working. Now it's detecting it, okay? Where's the black wire? There it is. I'm sorry, it's not detecting anything, which is good. Sorry, keep up with me, guys. I just proved that it's off. Turning my circuit breaker back on, turning my voltage sensor back on, double checking it. Now it's detecting it. Now when I turn the circuit breaker off, hear that? That means now it's off. Okay, so it goes from a steady tone to a beeping. Okay, that means that I now have the power off. Again, this one's still not going to work. Let's turn our circuit breaker back on. Now we're back over to this guy. Turn that on. And it's able to detect it again, okay? Now, when using a voltage meter, okay, or digital voltage meter or multimeter, whatever you want to call it, right? This one you're going to be a little bit careful with, okay? And the reason why is because we don't ever want to accidentally touch our 2 leads. If these 2 leads touch, that's no bueno, because now you're going to arc it, okay? And it's going to interrupt the circuit. You won't die, but it's not something fun to live through. So what I'm going to do is I'm going to touch one screw and the other screw on my light switch. Now I'm getting 116 volts, okay? I'm going to turn my circuit breaker off. And now I've got no voltage that's actually going through it. Okay, so that's it. That's everything as far as the basics on ensuring that you're working on everything completely de-energized. Now, I'm not going to take this thing apart, and the reason why is because if there's some of you guys that want to see how to do a repair of a switch or repair of receptacles, I'll do that in the future if you want to. If there's more explanation you want out of the circuit breakers, I can do that as well. Not exactly sure what my next topic is going to be because you guys are not really giving me any ideas on topics, so I'm guessing you're just kind of watching these and you're just kind of good with them. But I look forward to seeing you guys next Saturday. Take it easy. Okay? And Oh God, I can't do that. Next one I'm going to show you. Fuck. Sound. Now, if I were to turn my circuit breaker off, this right here being my circuit breaker, I fucked that up. Going across the drywall. It was off.